We've seen the end product. We've seen some of the ways you've gotten there. So tell us where you're going next, right? So there's
All right, well,
another
I'm gonna go
iteration.
over there to the next one.
Okay.
He's gonna follow me somehow. Get my coffee out of the way. This is the next version of the filler bag. It's not working yet. I'm still putting it together. We start with the pump stack. This is all constructed from the 80/20 aluminum.
Yep.
It's got space for 6 pumps and a lot of 3D printed parts. The little base that it sits on, these little bumpers at the end. If we come over to this side, I actually built in a mounted power supply.
Oh yeah, right.
Because every one of these pumps takes 24 volts, and previously, basically you had to have a little power brick for each one. So that's just crazy. So what I did is when I put this together, let's see if I can, this is heavy. This is all wired in together. The white are RS-232 between each of the pumps. Every one of the pumps got these little power connectors that kind of hook each one up, so it's really self-contained. It was kind of overkill to put the voltmeter on there, but it looks kind of nice.
I like it.
When
Yeah.
they're all running, it's actually helpful to know how much current we're drawing.
Hey Steve, are those are the pumps daisy chained? The signals?
They are.
Okay.
And that's one of the things. That goes to an electronic thing. They're daisy chain serial.
Right.
So that means that if you're talking to one pump, if you say here, set the volume, then it works. But if you're talking to multiple pumps, you have to address each one.
Right.
They have to agree to not talk when the other guy is, but it's common that they'll talk all over each other when you just get the software going. Last year I bought a Keysight 4-channel scope, and it has serial protocol code. This has rocked my world because I can put a scope on there, and I can tell that the signals were garbled because 2 walked on top of each other. I think I told somebody that if I hadn't had this scope with serial protocol decode, it would be until the heat death of the universe before I got it working.
I totally get that. Yeah.
So that all comes into the phase duct. Now, this isn't running right now, so I'm actually going to kill the power because I haven't set this up here. I did this all at home. Again, I use a beagle bone. There's a little IO expansion cape. And I have kind of a little a buck converter.
Yep.
These are outputs of 5 volts, strictly USB, to power the beagle bone. Plus, I'm going to use a tablet as a little control interface, and this is just power for the tablet.
Okay.
Just a little bit of breadboarding. This white piece, I designed it to mount an RS-232 level converter, and it's got the little RJ11 plugs right on in. Plus, these are the prototype buttons. Obviously, for a real pump, we're going to have buttons somewhere where the operator can get at it easily.
Sure.
But this is just for testing. A little speaker, because I want to have beeps and boops to let the operator know what's going on.
I think that's extremely helpful. Audio feedback, it's awesome.
Because you don't want somebody to have to look at the screen.
Correct.
And the beeps that tell somebody, maybe it messes up, somebody starts the process and they walk away, you want it to go beep, beep, beep or something.
Precisely.
Where it's going to be particularly useful, though, this is where the filler is going to be, and I call this the filler bot universal. The idea is we also can fill these cytology collection vials, which they take the same fluid, but it's 20 milliliters instead of 3 in the COVID. And right now we use this very, very old Filmatic. I think it was built in the early 70s or maybe even late 60s.
Okay.
And it works, but it's one at a time. So here we'll be able to stack these up, and we'll have 3 heads. The tubing is going to come through here on this drag chain.
Got it.
And then feed out to the pumps. Unlike the other filler bot, which was 2 axes, this is just 1.
Right.
It dramatically simplifies the construction. So we'll expand by going down.
Yeah.
This will do 3 at a time, but when we're going to do the COVID vials, we'll replace this head. These are all coming apart, 3D printed stuff. There'll be 6 heads, and it will be adding a motor to do the drive,
Okay.
switches,
Okay.
and all of that.
Sure. Wow. That I love the modularity and the flexibility there. That just makes total sense for the next
It,
level.
I think so. It's going to be it's a lot simpler. I think two axes is it's much more difficult because you've got a much longer lever arm
Yeah.
as things go out. Other people have suggested actually basically moving the whole thing and basically orienting it this way so you could do two axes and it wouldn't be quite so tough. I think keeping it this way is going to be good enough. We'll standardize on these pump stacks. I have aluminum cut for doing 6 pump and 3 pump versions. We're not sure how we're going to do that. If you're just going to do this, will probably do 3 really well. And
Well, you know, Steve, something that we've found too is a lot of times, if the machine is simple enough, uh, what I like to do is I like to scale and get more throughput by just adding more machines, right? And so instead of building a
correct.
much more complicated, larger single machine, just have lots more small, simple machines. And there are actually a number of advantages of that. So I actually like the approach that you're taking.
Well, so the other reason we do this is because I'm hoping this is universal. We'll make a handful of these for the cytology fills, a handful for the COVID fills, and we'll be able to keep these in stock in case something breaks. If the original filler bot broke, that's the only one we have, and
Right.
that makes everybody a little bit nervous.
Yeah, yeah. No, that's absolutely true. The redundancy is key because you have a single point of failure over there, and this would take care of that. But also, I love that modularity because basically, and we've done that here with actually our automation, our production folders, is the base, which is the most complicated part, is standardized, and then for the different size products, we just have a smaller, simpler folding unit that just attaches with 4 screws into a fixed position. So it's the same kind of concept, and that way you can adjust your production. I think it's the perfect blend between redundancy and flexibility. So I think you're going in the right direction.
Well, and also because they're simpler, they're easier to build.
Yeah,
The first one is always the one that takes the longest.
that's right.
As we were prepping this morning, I was talking with Mike at some length about this, and we actually thought, raising this up might be important to give some clearance for the tubes.
Right.
So maybe if this is a little higher, you don't worry. You definitely don't want anything to rub as the tubes come up from this drag chain over here. So maybe we make this another inch or two taller. I don't know.
Well,
That's why
but
you test.
that's the beauty of the 80/20 also, right? Because that is a very simple change to make in your before you go to production on multiple machines.
Right.
But that also speaks to something that you and I talked about before in the run up to the show prep, which was this notion, and I've seen it myself. I think it's a universal law. You tend to see the more complicated solution first. The more elegant, simpler solution takes a while to come forward, and that's what I kind of see going from your first filler bot to this one. You've actually removed one axis and made it much simpler. Except I think you'll be able to match that throughput, maybe get a little better, but by increasing the number of machines, you can certainly do that. So I see that process working in you, and it just seems to be like a universal law.
Well, that's why you have ideas. A lot of my ideas I get from the operators here. These
Yeah.
people who work on the machines for hours at a time, they have ideas for little simple things. And you know what? Not every idea has to be $1 million idea.
That's right. That's right. I mean, that really is one of the fundamental principles of continuous improvement is lots and lots of little ones don't wait for lots of line drives don't wait for the home runs, right?
That's right. And as a matter of fact, when I was building the very first version of the filler bot, it had just a single nozzle. And because it was built on a plotter, it actually has a mechanism to raise and lower
Raise and lower, yeah.
whatever's at the end. And originally I had that thinking we needed to dip down into the vial. It turns out we don't need to, but I'm looking at this trying to make it faster. And it was actually my wife Jamie who said, make multiple nozzles
Right.
sitting off of the end. And it's like, duh.
Yeah. I mean, we've had that happen here so many times. Barbara will look over my shoulder and she'll say, if you just do X, and I'll think, man, why didn't I see that?
I'm surprised how much good inspiration I get from Jamie, who's only been here once.
Well, there's something to that, which is why I like what you said before about that notion of listening to the operators. Really, the people who are closest to the process very often have some of the best insights into that process. If we're humble enough to listen to them, you can really make a lot of progress, you know.
The nice thing I hear at Resolution Biomedical is everybody really is on the same team,
Yeah.
and everybody helps everybody else, and it's really been delightful. I have much more respect for people who work in factories. I couldn't do this all by myself. This has been a huge. We could not have been successful without the team here. Just amazing.
Well, and I've heard of stories like that across the country as people responded to the demands of the pandemic. But just to see it close up here, it's actually I don't want to be cheesy, but it's pretty heartwarming, you know. And it speaks to something that is really near and dear to our hearts, which is um, onshoring or reshoring manufacturing capacity. And that's just something I'm really, really big on. That's one of the reasons we build what we build our own product is because we believe in that. But we're also getting we're being drawn in a good way into educational um, uses for our product and actually developing some curriculum materials. And so I'm hoping that we can kind of bring young people into into the engineering world because of success stories like this, of what you're showing us right here.
It's really been a wonderful kind of confluence of a lot of things that happened at once. Um, COVID, and we already had a process for the cytology vials. I had availability and interest. We have other people who work on other aspects of this, and it all just came together. It's been a very exciting year here at RBI, that's for sure.
Well, and it's been really great for us because this is why we do these series. I've said this before in some of these series is our customers do the most amazing things, and just to kind of look over your shoulder over the last year as you've been doing this, when you first told us what you were doing and we started seeing pictures, we're like, this is why we do what we do to try to help accelerate that. And it's just really gratifying to see it kind of come together. So, well,
It's
what?
been fun sharing it with you guys for
Yeah,
however long it's been.
we've enjoyed
It
that.
turns
We
out,
appreciate it.
it turns out I found out about you guys because of a Facebook ad.
Yeah, we were talking about that and wondering how you came to us. I think that was it, right?
It was definitely a Facebook ad, and I looked at it and I thought, oh, this is great. And of course, I have a big love for the whole SR-71 little vibe you guys got going on there.
Yeah, we do.
It's,
But and that's why we really appreciate you taking the time and our other folks who have joined us for Facebook Lives before, basically to show how they're using this thing because there's such a wide different a range of
So,
things.
I have a question.
There's a question.
Right. We are considering inviting some folks from Beaglebone to speak, and I noticed that you're featuring Beaglebone in your builds. Why Beaglebone, and do you think this would be relevant for more people to learn more about that particular board?
oh, sure. I love the BeagleBone. I originally started using the Raspberry Pi, but Pi doesn't have enough, doesn't have enough I/O. Basically, I use the Raspberry Pi for compute, but anything where I need I/O or um, this has 4 serial ports on it, and right now, even in this, I'm using 2 plus the console. The other one uses 2. Adding in external stuff on the Pi was just too much. For building industrial equipment like this, the BeagleBone is perfect. That I/O is just crazy good and useful.
Yeah.
But
Yeah.
at my home network, I have 3 or 4 Raspberry Pis that do things like time servers, name servers. You use the hardware that's best for it. But the BeagleBone has been just delightful. The one I'm using here is the green Wi-Fi. You can see the little wireless antennas here. Again, I haven't powered them on here at RBI, but they normally just sits on the Wi-Fi, and you connect to it over the net, and because of course it runs Linux, I just SSH into it and run the software, and it's been just tremendously reliable.
That
Love
is
this.
great.
I love a good ecosystem. Again, nothing beats the Pi for a huge ecosystem, but the ecosystem around the BeagleBone tends to be more along for things that I want. I'm not looking to make sparkly LED things.
Right. And I think you're right. I think that is honestly what makes a given family of boards succeed more than anything else is the ecosystem, both for software development resources and also the additional hardware add-ons, boards, shields, hats, whatever they are.
Yep.
That's really what makes it. So I would definitely agree with that assessment right there. Yeah, we are thinking about having probably the two of the big dogs in the Beaglebone world, if we can twist their arm to join us for maybe 2 months out, and so we'll definitely let everybody know about that because in some ways the Beaglebone is kind of like the best of both worlds. It's kind of like a Raspberry Pi with real-time control so it's like a microcontroller wrapped up in a Raspberry Pi kind of approach. And
Really. Also, just to round out the micros, over on the Roser labeling machines, the little pauser button, that actually uses a smaller Arduino. It was a really simple application, just managing some buttons and sensors.
Yeah.
I didn't want to run an operating system that could be corrupted.
Right.
We're talking about a couple hundred lines of C code.
Yep.
So Arduino was perfect for that. I think you had Glenn on a couple months ago, right?
Yep. Yeah, and for a lot of the
Quite
stuff I
Arduino
do, I just use straight up Arduino because it's amazing how complicated you can get on an Arduino. And you're right, it's pretty bulletproof. Once it's flashed, it stays there.
It's been really good. On the Beaglebone, I'm doing the actual application is in Python, which I'd never used before. I was more of a Perl guy. But I like Python a lot. It's got pretty nice bindings for the hardware, so talk to the serial port or catch an interrupt from an I/O line or whatever. I really like it a lot. I'm surprised how much I like Python. I did find that trying to use Circuit Python on one of the Adafruit Metros, it was unusable. Won't take enough. You can't write big programs, no interrupts. Maybe I was doing it wrong, so I just gave up and went back to the Beaglebone.
That's interesting. That's something that I actually wanted to look at and haven't dabbled in yet. And so maybe that's something for a future Facebook Live. I'm curious about Circuit Python. Because I think Python in general it's an easy language to learn and yet very powerful. Now it's being so widely used. I'd love to see it. It is gathering steam. I'd love to see it gather more, but I don't really know much about Circuit Python, and so I'd be interested in hearing more about that. So we can talk about that maybe offline and maybe schedule that for some time out. That'd be good.
I'll fill you in a little bit later sometime.
Yeah. That's good. Is there anything else you'd like to while we're looking at here that you'd like to show us?
I actually can't think of anything. I think we have really drilled down and covered it all. We've got, you've seen all the things that matter here. I mean, except for the people, and it's really been a fun thing to be able to share.
Yeah.
We've gone through this a couple of days ago. We had done a little pre-check where I kind of gave you the little tour,
Yeah.
and we can kind of see what we're doing. I think we've covered it.
Steve, I want to thank you not only for what you've built out here, but also for how much you've supported us as a company. I personally, Barbara and I really appreciate that. Thank you for that.
One little company to another.
Yeah, yep, I hear you, and I'm a big booster of little companies. I really, really am. So, well, that's great. I think that that's a wrap for us. I'd like to thank you both, Steve, for a fabulous presentation, Mike for helping out. Y'all guys, Mike, come on around in front there and y'all wave and we'll shut her down here.
Hey, how you doing?
Thanks,
Thanks
Mike.
very much.
Thanks, Steve. You guys are
Appreciate the
awesome.
opportunity.
That was great. It was great. And we love what you guys are doing.